I got to record my physics class earlier. I'm gonna have to go back and redo that. I have to lecture to myself while I'm recording myself. That's always fun. I hate doing that. Yes, it does.
Want to take a look? I figured we would use a 9-volt panel. Just
So
in
you're
case.
making a functional diagram here?
Yes. And then we would connect the panel to, well, this would be connected to the actual DC-DC boost board.
Mm-hmm.
We set it to 5 volts before connecting it to the Arduino. Because most Arduinos work at 5 volts. Then we would also connect the Arduino to a battery holder.
Okay.
And then the load would be the software being.
I'm not entirely sure that this is what you want to do. I don't think you want to use your Arduino as your solar controller. I think you want to have a separate solar power system that has its own controller.
You think?
Yeah, I would look into that.
Okay.
Okay, so last time was all about last on Friday. We were just extending the time working on, gave students time to work on a Gantt chart, PERT chart thing, and that came from Wednesday. On Wednesday, we learned from chapter 2 about how to build how to write down a task list for a project, how to build a Gantt chart from the task list by calculating predicted times, and then how to build a PERT chart from a Gantt chart. Now, if you weren't here for any of that, if you'd missed that class, I did record it. It is up on YouTube. As soon as and on Wednesday we learned how to do that stuff. Just we learned about those things and kind of pointed everybody in the right direction on how to do those things. But then we chose a project for students to actually apply these things to. And for the people, there were only 2 people here when we did that. It was just the 2 people here in North Platte. And so if you weren't here or you didn't watch that video, then you're probably not aware that we've started a project. The project that the students here chose to do is a project where they're using an Arduino microcontroller to monitor and record data from some sensors. And then they're going to use the Arduino to also push that data into the cloud. And part of the design project also includes powering the Arduino using power that will not have to be changed constantly, not have to be maintained constantly. So, either solar or a battery that will last long enough so that you only have to change it maybe once a month or every couple of months. So the idea here is that we've given them a project to do, and the project, essentially, we just tell them what we're looking for, what we're trying to accomplish, and they have to figure out all the things that need to be done to accomplish this project and then start to carry out those tasks, right? So that is a project that we can add more people to that project if that sounds interesting to people. But if you're out in McCook and you'd rather do a different project on your own out there, or if you're out somewhere else and you'd rather do a different project on your own, then we're totally open to that. We just need to come up with a project for you. The idea here is that for the next few weeks, we're going to go through the different chapters of the book, Engineering Design Process, and we're going to apply the different skills in each chapter to an actual project. So while we're learning the skills in the book, we'll be applying them to whatever project you choose. So since most people missed Wednesday and Friday, your job for this week is to watch the videos from Wednesday. And I did turn on a video for Friday, but I didn't upload it because it was just, I turned on Zoom so that anybody that connected, we could talk with and they could ask questions about doing their Gantt chart and PERT chart. But what you really need to do if you were not with us on Wednesdays, you need to go back and watch Wednesday's video and learn about task lists, Gantt charts, and PERT charts. And then you need to decide what project you want to work on. You can work on the Arduino project if you want, in which case we will make assignments to different people for different parts of that project. But if you would like to work on a different project, I do have some other project ideas that I'll talk about today. And if there's a project that you want to work on that you know about, and this can be a project, the project needs to be some kind of an engineering design project where somebody has a problem that needs to be fixed or solved, and that you're going to design something to solve that problem, to fix that problem. And then you're going to design it and build it and test it and everything else. If you don't have an idea for a project, the project ideas, the projects that I have that are still available here, my students started a project last semester where they were looking into the parts needed to design uh, an affordable do-it-yourself geothermal heating cooling system for like a garage. This cooling system would be would be cooling in the summer, heating in the winter, but it's using water, groundwater, essentially to do its heating and cooling. So essentially, groundwater at about 8 feet underground in Nebraska is about 50 degrees. And so the cooling that you can do is done with 50-degree water, which is much warmer than normal air conditioning, for example. Air conditioning uses much colder fluid than that. So we're not going to be as good as air conditioning. And in the wintertime, it will be warming a room using 50-degree water. So you're not going to get nearly as much warming power as you would with a heater, which uses much hotter air than that. But the idea is to have it in a space like a garage where you don't necessarily need to make the garage super warm in the winter or super cold in the summer. You just don't want it to be super hot in the summer and super cold in the winter. You're just trying to bring the temperature up a little bit or bring it down a little bit to make it, livable or just, doable, workable. But anyway, what we did with that last year was we were able to collect the materials. We got all the materials and stuff together, most of them anyway. There's still some things that need to be done in that regard. And we tested the parts. We have a water pump that was tested. We have solar panels. I don't actually know if they tested the solar panels. I think they did, but they also tested some fans that we've got for this. And so there are things that would need to be done to complete that project if we wanted to do that. Other projects, let me think. I had another one and I can't remember what it was. We have another unfinished project that is that one's kind of on the shelf because the client for the project has decided they don't want to pursue it anymore. So I'm not sure that we can pursue it anymore. We'll have to think about that. That's a windmill project that we probably will have to think about some more before pursuing. I actually can't think of another project that we have. The Arduino project is it's for a professor at the University of Nebraska. He's trying to put together this low cost kind of open source platform for collecting data for farmers. And so it's kind of a farmer service thing. We're doing a service for farmers with that particular project. The other project is a similar thing. It's more of a do-it-yourself project for people who would like to use it. It's not, none of these projects are projects we're trying to make money with or anything. They're just projects we're trying to do something interesting, and we may end up publishing something about them so people can see what we've done and they can repeat the results of them. The idea of these projects is to get as close as we can to a real engineering project. So the projects should be something that you have to figure out what the actual problem is that needs to be solved, that you actually have to work out all the things that need to be done in that project, making a task list. And that's what a task list is. So you're writing down all the general things that have to get done for the project to get done. Everything from going and talking to people, doing some research to figure out what the problem actually is, to make sure that you understand the problem, to make sure you understand, the thing you're trying to solve, thing you're trying to do, the thing you're trying to design needs to do in the end, to researching different parts, researching different design options, different how things might work within your design, how they might connect to each other, but also putting together a Gantt chart from your task list, which a Gantt chart is a way of organizing your time with your different tasks to make sure that things are following within a timeline kind of thing. And then a PERT chart, which is a way of organizing the priorities in your project to make sure that the most important things are getting done with priority. So, and for more information on that, once again, I point you towards the video from last Wednesday, which is where we talked about task lists, Gantt charts, and PERT charts in great detail. The idea of these different charts and lists are just the beginning of a project. These are the things that help us to understand what the problem is and how we're going to go about it in general without actually looking at anything technical. By the end of your Gantt chart and PERT chart, you really shouldn't know anything about the design at all, except you should know what the overall design should do. By the time you're done with your Gantt chart and PERT chart, all you really know about the project is a list of general tasks that need to be done and kind of an overall view of how you're going to go about doing them, but not anything more detailed than this. The idea of the engineering design process is every step in the process you get more detailed. You create more detail in the design, and you understand more about this, how you're going to solve this problem. And then towards the end of the process, you have so many details that you are actually working with a design that has all the details filled in, all the the T's crossed and the I's dotted, and you're actually designing something or building something or testing something that is a real solution to the problem that you started with. You don't want to do everything at once. You want to start off with very general things to kind of map out the process, map out what you're going to do during this engineering process. And then towards the end, you're actually, choosing nuts and bolts and wiring things together and actually testing it, because you've gone through this process of very general to very specific. So that's the idea of what we're going to be doing for the next few weeks. I want to get everybody into a project, deciding on a project that they're interested in, and putting together a task list, a Gantt chart, and a PERT chart this week. Okay, so the first thing then, of course, is you need to choose a project that you're interested in doing. So Hunter, since you're the only one live on with us right now who hasn't chosen a project, do you have any questions about all of this that I've laid out for you?
I think if I just watch that video from Wednesday, I think I'll understand it better.
Okay. Do you have any thoughts about a project you might be interested in?
Currently I do not, and just not for sure yet.
Okay. So tell me again, I'm sure I've asked you this question, but tell me, what are you interested in as far as engineering goes? What do you have a particular interest that you're looking at as you go into engineering?
Yeah, I'm interested in like the construction side of it.
Construction engineering? Okay.
Yeah.
So as far as construction engineering goes, I'm not sure. I'm pretty sure I could think of a project that you could work on that is related to that if you want to do something related to that for your project. You don't have to. It doesn't have to be related to something that you're interested in going into. It can be any project really.
Mhm.
But I think that I could come up with one if you're interested in it. Go ahead and think about that. Go ahead and watch the videos from Wednesday, and think about a project that you might have in your area that you might be interested in, or the projects that I've mentioned, either the Arduino sensor project or the geothermal heater cooler project. Geothermal heater cooler project is somewhat related to construction engineering, not super related, but somewhat.
Okay.
The project that I'm thinking of actually is I actually there I actually purchased a house recently, but I'm trying to sell the house off of the lot. So I'm trying to sell just the house and not the lot. I want to keep the lot.
Yeah.
The problem with that is that the house is built on top of a basement, a half basement. It's essentially half in the ground and half out of the ground. So if this house sells and somebody comes and takes it off of the basement foundation, I will be left with a big concrete box that needs to be covered because I don't want it to fill with water and get animals and all kinds of stuff in there. I would like to preserve the concrete because eventually I would like to build a swimming pool in the place where that concrete is. Essentially, essentially, if I sell this house, I'd have a pre-dug and pre-concreted swimming pool foundation, which would be really nice because that's probably $20,000 of the cost of a swimming pool. It's more than half the cost of a swimming pool. Maybe even more than that, actually. It's probably more like 40,000. But anyway, that would be a project to cover an existing foundation without at the lowest possible cost, essentially. Figure out a way to keep snow and wind and leaves and dirt at the lowest possible cost. And it would probably be, can it be done for $1,000 or less? And will that hold up to weather and everything else, that kind of thing. So that's a possible project if that holds any interest for you, and you can think about that. If you did choose that project, then your first steps into that would be putting together a task list. But as you're putting together a task list, you need to be asking yourself questions like, what problems am I trying to solve? And if you're not sure about what I said about what I want, the problem I want solved, you need to come back to me and ask me more questions. Or if there's something that needs to be cleared up, or if you come across something that, if you come across some kind of building code with a city that, only allows you to do certain things certain ways, you need to come back to the client, which would be me. My other students are doing a project where their client is this professor at the university farm. And so when they have questions, they have to meet with him and talk to him to try to figure out what the actual problem entails, what it is, the problem that you're actually trying to solve actually is, to make sure it is that. Because if you come back to me with let's just get a really heavy duty tarp, well, a heavy duty tarp causes its own problems because maybe you never asked me what the size of this hole is. And maybe there's no tarp made that will cover this hole, right? Those kinds of things come up all the time where you're thinking one direction, but the problem is actually in another direction, right? Or it has multiple facets to it that you have to account for. So the beginning of this project idea is really all about figuring out what the project is all about, figuring out what needs to be done, what the problems are, and trying to write down as many of those problems and figure out the path that you're going to take to solve those problems. You're not actually trying to solve the problems. You're not designing anything yet, because designing things requires a lot more understanding of the problems and the project. So you shouldn't really try to design anything at least for 2 weeks. before, it'll be 2 weeks before we actually try to design anything that we're going to actually build and test. So that's a common thing that engineers often do is they start designing right away because the designing part is the fun part and the exciting part. But the problem with getting involved with the design part right away is that we often forget what the problem is because we're too busy designing. We forget simple things that were part of the problem that in our design are not accounted for because we forgot what the problem was, right? And the problem can sometimes be very complex and have many different kind of arms and legs to it. So hashing out what the problem is for a week or two actually has a lot of benefits down the road because then we don't have to redesign because we forgot something, or we don't spend a lot of money doing something that wasn't actually part of the problem, that wasn't something we were trying to fix. It's a very common thing that engineers do is jump into design right away. So we're going to try to put off the actual design and go through this process of making sure that we have the problem nailed down before we actually start designing anything. And then as we design, we'll design in a very methodical fashion so that the design comes together without leaving the problem behind. So does that make sense? Kind of what we're trying to accomplish. Hunter, does that make
Yeah.
sense?
Yeah, it does.
All right. Oh, good. All right. So now that we're, let's see here. Now that we've kind of caught you up, I'm hoping that everybody else will watch this video and the previous video and be able to get caught up without any trouble. This week, by the end of this week, I want everybody done with that. And I'm going to go ahead to the calendar and make sure that that is reflected in the due dates of these things. So this is the homework from chapter 2 includes these Gantt charts and PERT charts and task lists. Oops, if I want to do here. And that is technically due today, but we're gonna push that off a little bit until we are sure that everybody's watched everything and listened to everything and had a chance. We'll push it off till Wednesday at the end of the day. Hopefully then on Wednesday we will come back and be able to communicate with everybody and help them finish that up, help them answer any questions they might have about the task list, the Gantt chart, the PERT chart, help them finish that up and then move on. What we really would like to do is move on with other things as well. Next week, we've got our homework assignment that's actually something we talked about already. It's a teamwork thing, and I'm probably gonna modify that. So everything next week and the week after, I'm going to actually push off down the road and probably change a little bit as I'm changing this. The next chapter in chapter 3, we learn about ethics, which is quite important. That's what chapter 3 is all about, ethics. And we might actually push that off until after this project, before the next project, and go to chapter 4, which is requirements. And in the chapter on requirements, which is chapter 4 and chapter 5, essentially, identifying needs and gathering information, and then customer requirements. We're going to be putting together objective trees and function diagrams. So we will probably put those two in for next week. Probably we'll get in the project requirements and objective trees, and we'll probably start talking about those depending on how we're doing with the previous things here, the list, the task list, and the PERT charts and everything else. We'll probably go on to the objective tree and the function diagrams starting maybe Wednesday or Friday this week, and learn how those are built, learn what those are all about, learn how to use them, learn how to make them. And then you'll go ahead and make a project requirement and objective tree and a project function diagram as well for your project. Now, these things, the project requirements and objective tree and the project function diagram, you're going to find are very similar to the task list and Gantt chart and PERT chart. They're very similar to that. In fact, all they really are is an extension of this with more detail. It actually is going to inject the task list and the Gantt chart into an actual pseudo design. It's kind of like building a flow chart of your design using the things that you need to accomplish from your task list and your Gantt chart and your PERT chart. So this is an example of going more and more detail. So this week we're working on PERT chart, Gantt chart, which is more like organizing our thoughts. But next week, it's more like taking those thoughts about how the project is going to go and kind of making them into, or putting them into the parts of the design that they're going to fit into. It's kind of like fitting the tasks into the design. So, and then once we've done that, then we can start thinking about the actual design and how it's going to go together. And then once we've done that, then we'll actually be designing. We'll actually, it's almost like getting into a cold pool where we're just gonna, a little bit at a time, we're getting into the design pool where we're starting off by just thinking about the project, and then we're taking those thoughts and kind of putting them into a pseudo design, and then taking that pseudo design and actually morphing it into a real design that we can actually make a prototype of and start testing and seeing if it works. And the reason I talk about this so much is because I found it's really difficult for students to visualize this, to understand what the design process is about. They're like all engineers, they just want to jump in and start drawing pictures and figuring out how this is going to go together. And for a very simple project, that's easy to do. But as your projects become more and more complex, more and more involved, it becomes less and less easy to just jump into it like that. Jumping into it like that can be devastating to the project and to your career. You really just don't want to do that. So next, starting maybe on Wednesday, depending on how people are doing with their PERT and Gantt charts, and hopefully for sure on Friday we'll be doing this. We'll be learning from chapters 4 and 5 in the book, which are about project requirements, objective trees, and project function diagrams. And we'll do a bunch of examples. We'll go through a bunch of examples with example projects, and then we'll help you to get started on building these things with your own projects. And that's what you will turn in next Tuesday and next Friday, is you'll be turning in these things that are actually built up around your project that you've chosen. Then once we're done with that, we'll move on to chapters 6 and 7. And chapters 6 and 7 have to do more with the actual design. So we're actually putting together a design on paper. We're working out how things are going to work together, how things are going to interact with each other. And that's what chapter 6 and 7 about. So actually designing, and that comes with the project morphological chart goes in there. And we might even work on, we might even teach you a little bit of CAD in there somewhere. But after that, then we're actually testing and prototyping. And that hopefully will get us to where we need to get. Now, the reason that I'm working this out here on this on the calendar is because I'm trying to leave enough time for our final going out into the community project and doing that out there. We want to have at least 6 weeks for that. And that's something we also need to talk about today so that you remember what it is. So for the last 6 weeks of this class, which if we go to the end of the class, which is here, this week here, we have 1, 2, 3, 4, 5, 6. So that's the first week of November, essentially. The first full week of November is where we want to start our community projects. So, and that's the latest we want to start them. So we have half of September and half of September and all of October to work on this project and get everything else done in this class that we want to get done. See here, this stuff all down here. Make sure we get this laid out kind of properly. Okay, with the stuff that we've already got scheduled here, we've got only, we'll have 1, 2, 3 weeks, maybe 4 weeks after we're done with what we have planned to get your projects completed. And that's barely enough time to get a very simple project completed. So it's very likely that the projects that you're working on right now will not be done by the time we're done with this. And we have to move on. But that's fine. That's not the point. The point is to get practice using some of these tools that you can use to organize and make a project happen. So the next thing that we want to talk about today, which is the last thing we're going to talk about today, is the next part of this project. The next part of this project is the project logbook. So let's actually put this up to here. We'll put this up to Friday, I guess, project logbook. So your project logbook is where you keep a record of everything that you do. Let's take a look at this, what this looks like here. I don't remember what it looks like. Yeah, so what I've got here is I'm actually gonna make a different one here so that I'm gonna do it right now, actually. So the project logbook, what it needs to do here, what you need to do with your logbook is you need to decide where you're going to keep a record of the things that you do on this project. And you need to record everything that you do that is important to the design or important to the overall success of your project. Anything that you do that you think made the project work out somehow, that was important to making the project go, you need to record. And the reason you need to record this is because if somebody comes along and wants to repeat what you've done, they're going to use your logbook to try to repeat it. So they need to see everything that was essential. That means that you're going to record some things that are not so essential because you thought they were essential, but it turns out they weren't. But that's fine. It's better to have more stuff than less stuff, but you don't want to have everything. You definitely don't want to put in your logbook things like, well, Joe and Fred and I met today and we decided that, we were going to meet another day. That kind of stuff is not necessary, right, in your logbook. But if Joe and Fred and you meet that day and you decide that the cabinet that you were going to purchase isn't going to work because it's not airtight and you need it to be airtight, then you probably need to include that because that obviously is important. You've decided on something that's important to the project, so you include that. The cabinet needs to be airtight. We decided on that this day. And you may even include why you decided that. Maybe you did a test out in the field with the first cabinet you chose and it just failed for all kinds of reasons. That information would be important so somebody doesn't buy the same cabinet again. So what we're going to do here is I want you to, in this problem here, let's see, I want this to be a file. Let's see. No, I'll just make it a short essay question kind of thing. So I want you to share a link with me, a link to your logbook. Just paste it. So you're going to create a logbook. Um, and then you're going to share that link with me. Let's see, let's save that done. And then when you're done with that logbook, when you're done with the project, I will come back and grade it based on how well you kept your logbook, essentially, how many, how complete it is, and the actual content that you included. So when you click on this, it'll have two questions in it. And one question will be, did the student make sufficient entries? And that's where I'll put your grade for the overall logbook. And then you'll also get half your grade just for pasting a link to your logbook that I can actually view. So all you need to do this week is to put your logbook, to create a logbook and paste a link right here. You don't have to do anything with the first question, because I will grade that one. I will put in the grade for that one by hand. Does that make sense to everybody, how that logbook homework assignment goes? Yeah. All you need to do is paste your link. Now, what does that mean, paste a link, and what are you going to do for your logbook? Where you keep your logbook is completely up to you. I found that these document share websites are the best place. You can use Google Drive, make a document there, and save a logbook there. You can also do it in Microsoft 365 or whatever it's called, where you have a document that's being saved in the cloud, and you only change it in the cloud, and multiple people can have access to it at all times, so that everybody can see what everybody else is doing, and so on. If you're not sure how to do that, it's actually fairly easy. If you have a Google account, you just open up your Google account and you go over here to the little tab here that has all the different apps, and you go down to Google Drive, which is this triangle thing, right? Oh, I haven't shared my screen. Let me share my screen. I forgot that I didn't share my screen. So here, here's what this looks like. You go to the little apps button up here and you choose Google Drive, and it'll take you to a Google Drive. It's essentially just a bunch of files. If you have files in it already, then they'll be there. If you don't have any files, this will just be kind of an open, empty page. I've got tons of files here because I've used Google Drive for decades. But here I actually have some, well, not there, I don't. I should have somewhere some example logbooks, though. I'm pretty sure I've kept some here. Let me see if I can find one. Oh, yeah, here's one. So here's a project logbook from a previous team, and it's just a document. If you need to open a new document when you're in Google Drive, the way you do that is you go up here to New, and you just click on it, and you just choose a new Google Doc. Now it's going to give you the option to do a blank document or from a template. I would just open a blank one, or you can actually, I could actually post one, I guess, somewhere, but it's a really easy document to make. It's not hard to make. So this is what this one looks like that my students used before. Let me get rid of this and zoom in on this. How do I zoom in? 100%. So let's go like to 200% maybe. So this is what this document looks like. At the top of the document, usually you'll usually give it a title, but these guys put their emails at the top just so they were easy to access. and that's fine. And you can share emails and you can share phone numbers if you want, but you do need to be able to get a hold of people in your team. So if you have people that you're working with on your project, and you're not seeing them every day in school, then you might want to put up numbers or emails or something. That's totally up to you what you put up there as far as who to, what kind of information. You should have a name on the top, whoever's on the team. Here they actually have the name. They have a name for their team as well. So they were the mechanics team, because that was part of the project, was the mechanics part of the project. This was a project that was split into different parts, and this team was in charge of mechanics. They put a date on it, this 2018, and they also put a team leader on. They chose a leader. That's part of putting together a project. If you have multiple people on the team, you need to have somebody who is responsible for communication with the outside. Is responsible for whatever. Somebody who's in charge. And that's fine. And you can have multiple people in charge. Some people in charge of this, some people in charge of another thing. You can also have information at the top of your logbook. Your client, whoever you're doing this project for, their information may be up there. At the top of your logbook, you want information so that the person that opens this up knows what the project was about. And this one maybe doesn't have enough information for that, because you can't really tell what the project's about just by reading this. But so maybe you have just a summary of what the project is. You have a list of people working on the project, contact information. You have maybe team leadership information at the top of it, and timeline. So the dates when the project was going on, stuff like that. Any other relevant information that you think should be at the top of the logbook, fine, include it, whatever you want. But definitely you want to have kind of that fundamental information about the project at the top. And then this just runs kind of like a blog, essentially, or a journal, right? You're gonna have a date, and you're going to include the name of the person that is inputting the entry in the logbook, and then you're going to write down what they did. In this particular case, he's just writing down some functions here, or some questions about the functions of this thing, right? And then on November 12th, they actually write down a bunch of specifications. And these are things that are included in other things. Like you might have a task list that has some of this stuff in it, right? But the task list, when you make your task list, you should link that in here as well. You maybe even put it directly into this, but you could also put it into your Google Drive and link it as a separate file. And that's the great thing about using Google Drive, is you can actually create links in different documents to other documents. So you can have multiple documents in a Google Drive folder somewhere, and your logbook just has links to those things, and that can be very helpful, so that your Google Doc, that's your actual logbook, doesn't get too cluttered. So you might have an image of a drawing that you did, or you might have an image of a three-dimensional design that you did on a CAD program somewhere. And those things can be separate files that you just link to when you need to see them. Here they're actually making a list of things that, specifications that this robot must have. So they were doing a robot competition. Here we have somebody that's trying to write down the actual problem statement here, right? So this is a paragraph that describes what this robot needs to do in 4 or 5 sentences. So that's not bad. And you can see here that 3 different people worked on this, and the date. Here they've put together a Gantt chart, and they've just put it directly in here, along with their need statement or their problem statement, right? And you can see that their Gantt chart is very simple. It's not super detailed. As you move on through a project, or if you have a more complicated project, you may modify this Gantt chart. You may realize that, for example, they're right down here. They've got revision, corrections, final draft. Right. This is obviously not the design of a robot. This is obviously a Gantt chart for something else, something much simpler. They should have titled that maybe. And I probably took off points for that. But maybe they go through here and they realize, oh, we didn't make this Gantt chart to include things that we're doing for actually building the robot and designing the robot, and fixing the robot. So maybe this is about, writing a report or something, and that needs to go at the end of the project. And so somewhere in the middle here at the beginning or something, they're actually got time for designing a robot after brainstorming and parts list. Maybe they've got design the robot, test the robot, whatever, revise the robot, and that's built in the center, so they have a new Gantt chart maybe later on. Here they have an objective tree, which is something we'll learn about more. Here they have an actual, they call this a what do they call this? Design options, something or other. But this is essentially what are the different ways that you can maybe do things, and what are the different options you can use. And they're actually looking at things that were made for these particular types of robots, and how they could possibly use them to do different things. And these are all things that we're going to learn later on, and we're going to include in our logbooks. But really, as you go on, you should include anything that you do. So here they actually injected one of these things into a CAD program, but they didn't really. Or here they actually talk a little bit about things that they're doing. They're trying to make a decision in there, and they've called each other, and they actually put the results of their phone call on there. They said, well, we might use this one or this one. What are the ups and downs? And they chose one over the phone. They included that in their logbook, that conversation, or at least a little thing of it. This logbook doesn't have nearly as much as I would expect from a project, because really anytime you work on the project, you should enter something into the logbook. And you don't, I mean, if you just got together with people and you were working on something, but you didn't end up making any real changes or decisions, or nothing really happened that you think was essential to write down, then you still record it, because you want people to know that you were working on it. Just say, this is the date, this is my name, this is what I did today. I worked on this, trying to assemble this, and I didn't get it assembled. It needs to be assembled still. Just something simple like that, so that people know what you did in your team, and they can come along and look at the logbook and say, oh, he worked on assembling this, didn't get it quite assembled, maybe I can finish that, or maybe I'll work on something else while he's finishing that. Just so people know what you're doing. If you're doing something that doesn't really have any really important information that needs to be put in the logbook, just make it short and sweet. I worked on this, done. But if you worked on this and you broke something, and you think that the design or the thing that you're using needs to be changed because it broke too easily or something, then that information needs to put it in there. Maybe even take a picture of what you broke. Or if you were working on, if you were looking up different types of springs that you could use for this part of the project, and you found 3 springs that you think would work, you would want to list those springs in the logbook, maybe even put links to them online, and maybe even put pictures of them and explain why you think these are the ones that you could use for the project. What their properties are, their specifications, any particular details about them that are going to be important to the project. That kind of information is really useful to keep around. If you need to keep the information for any reason, keep it in the logbook or link it in the logbook, one way or the other, right? The logbook should have all the information somebody needs to go back and redo the project, and not really have to think about anything, not have to go and reinvent the wheel anywhere. They should be able to just follow through your logbook and get all the information they need to do this project and to do it well. So more is better than less, but don't put so much in it that becomes useless information, essentially. Now, I always like to show this. There's a particular logbook out there that I love, because it's a real logbook from a very historical time in engineering history. And for those of you that are interested in computers, you will really like this. This is a really big deal when it comes to computer science. So this is an actual logbook entry from the 1950s when they were working on computers, big electrical computers. What's that? Oh, just I just typed in logbook bug. But this is an actual logbook, and it's actually in the National Museum of American History. But this logbook, this engineer was working on computers, and there was a problem with the computer. It wasn't working.
I know the story.
Back then, computers were in these huge rooms because they had lots of big electronic parts in them that needed to be kept clean. And so they were kept in these rooms that were free from dust and free from everything. And the engineer went into this big room and he was actually looking through all these big electrical parts to try to figure out what was wrong. And he actually found a moth stuck in one of the computer parts, one of the electronic parts, and it had actually shorted it out. The electricity had gone through the moth and it had shorted out this computer part. And so he pulled the bug out and he taped it into his logbook. And he said, this was the problem. We found a moth in there. And the reason that he did that is he wanted to show the size of the moth. He wanted to show that it was just a standard moth. And he wanted to show to people that we needed to keep these clean rooms cleaner. They started putting in fly tape and fly paper and moth traps and all kinds of things to protect these computers from bugs in the computer. And that's where the idea, that's where the terminology, I have a bug in my computer, came from. Now, when we say that, though, we usually mean there's a coding mistake. It's not usually an actual bug in the computer, but back then, they actually used to go into the computer and debug the computer. They actually would go in and clean out all the bugs with vacuums and everything else and clean out anything that might be in there, because when they first discovered a bug got in there, it shut down their program, it shut down their computer. So this one actually shows the first bug, the first recorded bug in a computer. So anyway, then you can see here that he has actual times. His times are in military time because this was a military computer. And he has the date there. And for most logbooks for scientists back in the day were pages that were numbered, and they had all kinds of things to put in for things. They usually had lines and graphs built into them. But on the very front of the book, there was actually a place to write the project that this book was for and your name and everything else and the date that it started and the date that it ended. In fact, my father had dozens and dozens of these things. And I think we still have them. I think my brother still has them. But every time he worked on a project, he recorded what he did in these books, and he had 100 of them or more when he was done, when he was retired. But we do this now electronically for the most part, and we want to keep these logbooks up to date. It's difficult to remember, so you need to get into the habit of, when you work on a project, open up the logbook. And what I would do is I would just open up the logbook when I walked into my laboratory, and I would start my first entry with my name and my date. And because when I was a graduate student, we were using electronic logbooks by then. But I just put my name and date at the top of the page, and I just write a first sentence, an opening sentence that says, in the lab, this is what I plan on doing today. And then when I come back to it while I'm working in the lab, if I'm working there for 2 or 3 hours, I'd try to come back to it every hour and type in anything important that I needed to put in, and include any data that I took and any discoveries that I made or anything that I'd learned about the project that needs to be fixed or changed or altered or whatever else. And come back to it every hour and just add some more to the thing. And sometimes at the end of 3 hours, I just had 3 sentences. Worked on this, worked on this, worked on this. And at the end, it's maybe, no new data, no new discoveries, no new anything, move on. And it's just simple like that. But other days it was, 4 or 5 pages of data that I took that I pasted into it, and all kinds of different things. We changed this, we we modified this, we found, then this happened while we were doing this. We don't know what caused it, so we need to figure that out. Oftentimes you put questions into your logbook. Oftentimes it's, this happened and we don't know why. Does anybody know why? You put in a question like that so that other people can see it and help you out with it. So the logbook is your next assignment. That needs to be done today. You need to have one logbook for every project or for every team on every project. You both should insert a link to it for me. And the logbook needs to be shared with everybody that you want to see it. I usually just make the logbook public so that anybody can open it, so that you don't have to constantly granting rights to it. And the way that you do that in Google Drive is once you've got your logbook open in Google Drive, like this. Once you've got your logbook open in here, there's a little button up here in the top right corner that says share. And if you have the rights to share this with other people, I don't have the rights, turns out. Looks like this belongs to one of my students or something probably. Oh yeah, now it's letting me share. So if you click on this share link, it opens up this little sharing window where you can add somebody's email to it, and then they can open up the logbook. You can choose what they can do. You can choose if they can just look at it or if they can change it. I usually just open up to everybody. To do that, you go down here to anyone with the link, and you click on that and you say restricted. So you can just send this link out. You can copy the link and send it out to people. And anybody who can open it, anybody who you've sent that link to, can just open it and use it. So it's just essentially a public document. Yes, sir.
So would you like an individual document for each day or just like?
Nope, no, one document for the whole project. It's just a running tally of the things you're doing. And you don't want to go back and fix this document. Google Docs tracks that, so does Microsoft 360. It'll track when you enter things in and when you change the document. If you miss something, if you forget to put something in, just put it at the end of the document. You don't want to try to like doctor it up and insert things, because if people have read through your document, they'll usually just go to the end of the document and they won't go back and look to see if you've changed it. So people will miss things if you do that. Don't worry if you forget to do something and you do it later. Just do it later and get it done. And then that document just looks in the end just like a blog kind of thing or a journal, right? Just entry after entry. This is not a very good example of one, but I have some other ones too that might be better. Yeah, this one's a little bit better, not a lot better, but a little bit better. But anyway, so that's your assignment for today. Go out and get your logbook all set up and practice using it. Make sure that you try to use it every time you work on the project. If you've done anything on your project so far, for example, if you've put together a Gantt chart, then those are entries you need to make, right? You need to enter things that you've done on the project so far, and especially things that are essential to the project, essential to making this thing happen. Then as you go forward, make sure that you use it every time you work on the project. You're entering things into your logbook. Any questions before we're done? Okay, any questions out there, Hunter? Zoom land?
I don't believe so.
Okay, so go ahead and get that done today and then work on getting your projects underway. I'll talk to you guys on Wednesday.